Good afternoon. Sorry to make your lunch short, but let's start at 1:30. My name's Peter Arathoon, and my colleague is Shu Nakazato in the front here. We come from Meio University, which is in Okinawa, in the very southernmost part of Japan. And it's a reasonably small university, 2,000 students. Okinawa is, as I say, it's right down to the south. It takes 1 hour and a half, 2 hours, more than 2 hours flying to Tokyo. And it's closer to places like Manila, it's closer to Hong Kong, and it's closer to Shanghai, and it's closer to Seoul than to Tokyo. So that's the position. And we're in the Faculty of International Studies. So also enabled partly because of the position of the island. It was from the initiation, it was aiming to be a very international place. And so we have quite a few foreign students as well. And originally the lessons were meant to be bilingual, which faltered at the beginning, but there are new hopes for it now. And the problem, or whatever, we're looking at today is how to construct the term timetable, which is a bit of a headache for the office, the academic office, but also for us because we get dragged into the process of making the timetable. And there are more than 500 subjects each of the 2 semesters every year, and the usual problems of trying to avoid double booking of the same rooms and trying not to put the same person in 2 places at the same time. And there are a few different courses in the university which shouldn't try not to overlap them, as well as getting compulsory subjects available for the students to go to. And the elective subjects across different courses, they should be available as possible, which is impossible. So looking at the needs of the timetable construction, you've got 3 sort of people interested in it: the lecturers themselves, who are, if possible, for example, if they've got to do the same old lesson, computer literacy or something, 2 or 3 times during the week, for them it's preferable to fit them in the same day, and if possible try and take 1 day off somewhere if they need to do their research responsibilities. From the students' point of view, it's best for them to be no gaps in their schedule, so that they can take their time off or have a lie-in in the morning or go off for their part-time in the afternoon or something. And for the office, the academic office wants, if possible, as even a distribution of lessons as possible. Bus schedules, people coming in, making sure the lecturers are available to the students for as wide a period of time as possible, and different conditions such as making sure that the first-year students have, if possible, keep them in a routine of getting up early in the morning and pushing them all into a first lesson in the day, if possible. All these various things need to be solved. So it's the sort of thing which a program is basically best for. So just solve it with a program. But it's not quite so easy, and in the end, it still seems to be the case in our university that it's made by hand. And in a couple of other universities we've asked, it still seems the process. And then once you've ironed out as many problems as possible, whether using drawing pins on the blackboard or on the wall or whatever, and then you put it all into one big spreadsheet, which is quite a mess. There's a little bit of Japanese left on this one. The Monday, Tuesday, Wednesday columns up there, and this is just the first lesson in the day. So it's quite confusing to look at afterwards. And if possible, we would like to bring whatever skills we have to this and make it slightly more amenable to a little bit of adjustment after. We don't say that we can help in the first process, I'm afraid, but afterwards at least the final adjustments which need to be made, if possible, to help in that process by making a data visualization of this. And that's where Blender comes in. The sort of final here's the empty schedule sheet, and what we've managed to put on top of this is a photographic representation of each of the lessons there. You can zoom in a little bit for each day's slot. And at least here you can pick out fairly immediately with your eye facial recognition program roughly where each teacher is and find them reasonably easily. That's all very well, but if possible we want to make this completely automatic, starting with the Excel or spreadsheet Excel program, and press a button and import all that in one step into Blender. That was we had to jump through quite a few hoops to enable that in the first place. And the reason is because of the different data formats. There are quite a few inconsistencies in the format used by the office. So one person comes along, puts in one lesson, and then some other person comes along and moves that to a different date or puts in another representation somewhere else. And part of the problem is that Japanese input, I don't know how much you know about this, but inputting Japanese on a keyboard, do you know how it's done? I mean, they do have the Japanese characters, the phonetic characters on each of the keys, just beside all the alphabet as well. And that is one way of inputting the words phonetically. But 90% of the people use the representation using alphabet and sort of spelling it out that way. There's just a couple of examples here. On the left is the keyboard input, B-L-E-N-D, and the output you get is Blender. That's in the normal alphabetic mode. And if you switch it to the Japanese input mode, then putting in these letters, B-U-R, if I can just try it, B-U-R, B-U, and it switches into the phonetic representation for that, bu, re, da, Brenda, and that says Blender in one of the representations. And if we can just so that's one way of saying Blender, and go into the next cell and write, so perhaps the next person in the office comes along and does the same thing, and he or she decides to put it in this format. It's exactly the same characters, but there are two different sizes for this particular phonetic script. So that's also exactly the same representation, although when somebody else comes along to input it into some other program, it's a headache because it's a different character. Then there is, whilst I was doing that, might as well show you another one. This one we begin with here. There's again the different phonetic script, so it might be put in that format as well. But mono usually, so how do you use the keyboard, digressing a lot now, to input the Japanese characters? For example, the word on the left is kanji, which is the word for Japanese characters, Chinese characters, and you can spell that out, kanji, and press the space key to change the representation. And the first possibility it offers up is the correct one for the Japanese characters, but there are the same pronunciation for different words in the language. So this is how you feel about something, and there are different, completely different meaning words, but they're read the same way. So that's just a digression. Oops. Let's go with that. So the office still puts all the stuff back into the spreadsheet, which is, I'm afraid, Excel. So how do we try and iron out some of those inconsistencies? First of all, we had to create a complete database, really, of the central column there is the Japanese title of each subject. The right one is a subject as well. And the left one is a code number, which was in the database at university, except for the final alphabet, A, B, C, D, which represents the different lessons during the week of the same subject. So you had to add on that one as well. And in the same way, the teacher, which is the next column along, the teacher for those subjects. 3 different representations, one code number, the middle one is the kanji representation in Japanese, and finally the English version. And the reason for having all of these is the left one is needed for any sensible future automatic creation of student timetables or something like that. And the middle one is for the Japanese staff, and the second English version is for English staff, not English, but various other countries. And these can be put in different, if you've got the original, I'll show you the original. This is just for your benefit, the English version of the timetable, which is originally, when it's input in the office, is in the Japanese version. So the first thing is to put that into this unified representation from a pull-down list. So using input lists, so that the next person who comes along and puts in the same subject, it'll always be in the same format. So when you want to import that into Blender or whatever, there will be no inconsistencies. And then using that as a base, you can sift out just the Japanese version and print that out for the Japanese staff, or the English version for the English staff. So looking a bit closer to the solution, different visualization of this data, making a close-up there, you can see of one day's Monday, the first lesson, the teacher's pictures. And the funny person on the top right, that's not an alien or anything, that's just a person who didn't have a photo in the database. So he's maybe a part-time teacher or something. And during the import process, I'll carry on. Associated with each object, these are just cubes in Blender, and using the data down at the left, bottom left, to store only the English representation of the teacher's name and the subject name as the mesh name or the object name. And looking at the object name is just slight fiddling again necessary there, because the title of the subject is usually longer than Blender's 19 letters. So we had to cut off halfway through after 14 letters and then jump to the last 4 or 5 letters of the name, so that we could keep the ABCD description of duplicate subjects. Before we go to the summary, during the import process, we've put in error correcting to pick out the code name of teachers who didn't have any photograph data there. And we've also, the purpose of the program is not just a data visualization of the timetable itself, but also hopefully to make it a bit more useful to look at a wider range of data. So pulling in other data from different folders in the same computer, holding, for example, absentee data or test results or something like that. And so we've just, as an example of those, we've put on just a few of these objects, different data, which this is the error messages saying we couldn't find, what is it there? Graphs for these subjects, and we couldn't find male-female ratio graphs for these subjects. So I'll just pull this down a bit. So selecting a couple of these, you can see that if we rotate these objects, and I'm afraid we're not using any wonderful Blender game engine technology, which I wish we were, but the modeling environment of Blender is, as it is, it's so good that for our purposes, at the moment it's usable. So you can just rotate the objects and compare for different aspects of those data directly, or rotating the other way around. If I can rotate. It's not going to rotate happily. I'm going to zoom out a bit. Just pick one person, shall we? We'll put him in the center. also in different aspects. Sorry to make you dizzy. There's the male-female ratio graph, which is automatically imported at the same time as the photographs, and a different graph, for example, of some test result or something. But there are still other faces available on the cube, so we can put different data as it becomes necessary. And with the Blender's selection process, you can select, for example, the same teacher fairly easily, and just show where this one teacher's lessons are, see if there's any clumping in his weekly timetable, and, for example, superimposing just one person's weekly schedule, you can see that he's doing his job by coming in early in the mornings. The first lesson's there, and up to 3 lessons were allowed in one day, but if you go beyond that, it's found a bit excessive. You're meant to be spreading it out a bit more than that. So this person's coming in every day, which is reasonable. These down at the bottom here, we have the import scripts. Whoops. This is importing the script data from the Excel file, which has a macro button so that even the staff can easily save that in CSV format, and import that with this script. And then after that, once we've done the manipulation of the data, that's the purpose of this. One main purpose is moving these blocks, data blocks, representing one lesson, plus all the data associated with it, plus the teacher himself, moving that to, for example, 3 on the Monday. Well, let's make that 2 on the Monday and 2 on the Friday or something. So you can just move that across and dump him in a different timetable slot. And then after all that manipulation, then there's an export script, the same way to export that to CSV format. Yeah. Nothing mind-blowing there, I'm afraid. So what we've managed to do up to the moment is visualization of the data, and it's a complex data set because you can drag in these different image files, data files, hopefully also audio files and video files in the future, and providing an almost real-time interaction with this, which is a bit, perhaps at the moment, a bit beyond the office staff to be manipulating, but that's why the end point of the research is hopefully to provide this in the game environment, where not quite iPhone, but where you can just drag the data fairly easily around. So starting from Excel, exporting it to Blender in between, and automatically exporting it back to the Excel format. And then the staff can just, if they've been told that some change has been made using the Blender interface, they can use a pre-prepared import script, macro, in Excel itself, which will overwrite the previous data. And then that will be automatically changed into the Japanese format or the English format of those. That's about it. Thank you very much. A couple of references. Any questions? Yep.
This was the time representation of the schedule, but I think about geographic representation of the schedule, like you have each room represented and in the class, and then you could stack the lectures in it, like little towers of different lectures.
Very much. We haven't used colour very much yet, and there are, like the different courses or whatever, we need a colour block which you can click on and just pick up just those data, indeed. And using layers, which we wish, there are only, as far as I know, only 20 layers, is that right, of data? We need a few more layers to represent, for example, all the rooms which are being used, But yeah, that's something we'd like to do. Anything else? Hi. Whoops, sorry, yes.
You can listen. Can you hear me?
Yep.
Why didn't you choose another technical solution for your requirement? The classical solution for this problem is a database system like Oracle, MySQL, PHP. Something like that, more than something where Blender is in the middle of the
Isn't
solution. It's just test the Blender.
why are we using Blender instead of SQL or something? You mean, or Oracle database? We could use the Oracle database in between. I suppose it was an exercise as well for me. I'm one of those presenters today who isn't a developer and isn't an animator and sort of in between somewhere. So it was partly started out as my study, I suppose. But hopefully Blender's up to it. Any more questions? Okay, thank you very much. Thanks.
No. Will you be here now still?
Yep. Yep.
Yeah, I was wondering, I don't know if it's relevant to you, but we are still working on this 3D application platform. And the thing is that it's multi-user. So if you ever want to make that system like multi-user so that it's like a shared space where everybody sees them and you can interact.
That'd be great.
And it's like easy. We have now just a button in Blender that you can press and it starts a server and there other people can log in. And, I will demo it now.
Really? Yeah?
Yes.
Good. That's great.
Excuse me, I have same question. Why chose Blender? Because normally